SPH4U energy and momentum 3.5 conservation of momentum. So law of conservation of momentum states that if the net forces acting on a system of interacting objects is zero, the linear momentum of the system before the interaction equals the linear momentum of the system after the interaction. So this is given by the equation Pt1 is equal to Pt2. So the initial total momentum is equal to the final total momentum. So if we expand this out, it is m1v1 plus m2v2 is equal to m1v1 prime plus m2v2 prime. The prime signifies that is final. We can't use a subscript because we already have the subscripts from the first and second objects in this system. So here's an example of the law of conservation of momentum. So an object with a mass of 108 kilograms and velocity 9.1 meters per second east collides with an object of mass 91 kilograms and velocity 6.3 meters per second west. So net forces acting on the system is zero, and the velocity of both objects after the collision is the same. So what is their final velocity? First, let us set out our reference frame. So let's make north and east positive. And I'll draw out a diagram of what's happening here. So you have object 1 with v1 and object 2, v2. So they collided with each other, and then that becomes this basically, vf. So they have the same final velocity, and since they have the same final velocity, both objects basically combine to form one object for the sake of simplicity. So you know that m1 is equal to 108 kilograms, and that m2 is equal to 91 kilograms, and that v1 is equal to 9.1 meters per second, v2 is equal to negative 6.3 meters per second. That's because of our reference frame. So we know that v1 prime is equal to v2 prime, and that's equal to vf. So m1 v1 plus m2 v2 is equal to vf m1 plus m2. We have this on the right side of the equation by factoring out the vf from both terms, and this comes from the law of conservation of momentum. pt1 is equal to pt2. So in order to find the final velocity, we just use some algebra to move the m1 plus m2 to the other side. So yeah, this is how we would find final velocity. So we have 108 times 9.1 plus 91 times negative 6.3. So that over 108 plus 91, that is equal to our final velocity. So 2.1 meters per second is equal to vf. So as a quick teaser for the next lesson, this is an example of inelastic collision. It's inelastic collision because energy is not conserved. It is not conserved. I'll explain all about this in the next lesson.